We can talk about vectors in space, in other words, vectors in 3 dimensions as well, and generally we will be working in 3 dimensions. Here I've drawn the coordinate system. The positive x, the positive y, and the positive z axes have been drawn. Now there's many ways that you could be looking at the coordinate system in space. You could be looking at it from what I might call from behind the screen or in front of the screen or from above or from below. But I always want to make sure that you take care to draw your coordinate system satisfying the right hand rule. So if you imagine here, this little image here is an image of somebody's right hand. If I was to stick my fingers out kind of parallel of my right hand, and I encourage you to do this right now, parallel to that positive x-axis coming out of the screen, and then curling your fingers through to the positive y-axis, your thumb will point up on your right hand, and that will determine the orientation of the positive z-axis. So just try that right now. Put your right hand kind of pointing towards you away from the screen. Curl your fingers towards the positive y-axis and then let your thumb stick up, and that will determine the direction of the z-axis. If I have a vector v, it will require 3 components now, v1, v2, and v3. And if I look at the point whose coordinates, not components, but whose coordinates are v1, v2, and v3, that will correspond to the vector in standard position starting at the origin. So v is the vector from O to R. If I draw that same vector somewhere else, then it determines P and Q, and those have some coordinates that will differ from my O and R possibly. And we do the same thing as we do in 3 dimensions. We just subtract the x coordinates starting at the end point minus the beginning point. So x1 minus x0, etc. The length of a vector, same idea. Just sum up the squares of the components and then take the square root to get the length. There's a 0 vector that has 3 components now. So again, put an arrow over it if you mean the 0 vector. And we didn't talk about this in 2 dimensions, but there are what are called the basic unit vectors. And you may remember the notation for these. These are called I hat. I hat is the vector whose first component is 1, the second and third are 0. And then there's j hat and k hat, where we just move the 1 to a different spot. So all 3 of these are unit vectors. It's not uncommon to put a hat instead of an arrow over a vector that is a unit vector. We'll use that frequently, and we always do that for these special vectors I, j, and k, and they'll appear in bold in type instead of with the arrow or with the hat on top of it. And we will always use the symbols I, j, and k for these very specific vectors. In 2 dimensions, there's not really I, j, and k, but you could think of I as just being the vector 1, 0 and dropping that third component, and j as being the vector 0, 1 and dropping the third component. So there's only I and j in 2 dimensions. And you should graphically think about them as sort of these unit vectors pointing away from the origin. If you write them in standard position, and I goes to the point 1, 0, 0, and 0, 1, 0, and 0, 0, 1. So it's I hat, j hat, and k hat. And think about the right hand rule there. Your fingers of your right hand go along I, they curl towards j, and your thumb becomes k. Try it with your left hand and see how k will actually point down if you go in that order.